Hey team, I'm Maddie, welcome to Science Side Up, and today we're going to talk about how the atmosphere changes as you move vertically. Luckily, we're building on what we learned last time, so I could just keep my little drawing up. The first thing I want to talk about is temperature. In the last video, we learned about these four distinct layers: troposphere, stratosphere, mesosphere, and thermosphere. And actually, one of, if not the main way that we tell the difference between these layers is temperature, and specifically how temperature changes with height. Down here in the troposphere, temperature generally decreases with height. The higher you go, the colder it is. So if I was going to sketch that, let's say this is surface temperature, and then we decrease as we go up. But in the stratosphere, that trend actually reverses. So in the stratosphere, there's this weird spot right here where temperature is sort of constant, and then it starts to increase. In the mesosphere, this temperature change flips again, and we get a decrease. And then in the thermosphere, it again flips. So temperature increases with height in the thermosphere. If you're thinking to yourself that temperature increasing with height sure seems really weird, you're not wrong. There are special things going on in the stratosphere and the thermosphere that allow that process to happen. In the stratosphere, there's an excess of ozone, and ozone is really good at absorbing incoming ultraviolet radiation from the sun, and then it warms the air around it. So the stratosphere warms with height because of the presence of ozone that's here and not so much in the other layers. And then in the thermosphere, it warms with height that has more to do with like radiative interactions with that incoming sunlight. So again, it's something special and a little odd that's going on in these two layers. It's more normal for temperature to decrease with height as pressure decreases. We've talked about temperature, now let's switch gears and talk about how pressure and density are gonna change with height. Most people have heard of the idea of air getting thinner if you go up on top of a mountain, right? It's a plot point in most disaster movies involving Mount Everest. And that is a real thing that happens, right? There is less air up here than there is down here. And that all comes down actually to gravity. How pressure and density change with height all comes down to gravity. Gravity is what holds Earth's atmosphere in place. But the further something is, the further a little atom of air is away from Earth's surface, the weaker the hold of gravity is. That's because the force of gravity is proportional to the distance between the two objects squared. So let me write down that equation. The force of gravity is equal to a gravitational constant times the mass of the first object, so that would be like the Earth's mass, times the mass of the second object, so like the mass of a single oxygen atom, and then divided by the distance between those two things squared. So using my favorite kind of math, which is arrow math, if the distance between the two objects goes up, then this goes down and the force of gravity has to go down. And we'll get more into exactly what this means in terms of how pressure and density change in later videos, because there's some more stuff we've got to learn about how gases work first. But a good rule of thumb is that for every 5 or 6 kilometers you go up, the density of the atmosphere cuts in half. But, and this is something that I think is really cool, even as the density is changing, these percentages don't. So whether you are here at Earth's surface or up on top of our mountain, the air is still 78% nitrogen, 21% oxygen. There might just be half as much here, but the percentages stay the same. Okay team, that's all I've got for you today. I hope you liked this video, and I will see you all in the next one, the atmosphere. I missed an article adjective in there. Okay.